Okay, in order to solve problems involving linear relationships, we're going to use this EQO example, rental rates. It says the total cost of a banquet includes a fixed fee to rent the hall and a cost per person. Information about the total cost at 3 different halls is shown below. So we have Hall A about the number of people and the total cost, Hall B with a relationship with number of people and total cost, and Hall C seems to be missing. So I need to compare these relationships, and the way to do that is to look at the rate of change and the initial value for each hall. So I'm going to start by looking at Hall B because most of the information is already available in the graph. The initial value here is at 0 people costs me $100, and the rate of change I'm going to find by using this point as well as the point 5, 175. So if I draw my rate of change triangle, I can see that this is a distance of 5 people for my run, and a change of 1, 2, 3 grid lines. So it looks like each grid line, I have 2 for 50, then 1 must be at 25. So 3 grid lines is 25, 50, 75. So the rate of change will be the rise over the run, 75 over 5. The rate of change is 15. So that means that it's $15 per person at this banquet. Now, I also need to figure out the rate of change on the table of values that I'm given, so for Hall A, and I need to know the initial value. So I'm noticing here that 450 minus 275 is 175, and 625 minus 450 is 175. So I seem to be changing by the same amount every time. What I don't have is the price for 0 people. So if I change and go in the other direction then I'm going to subtract 175 to get to 0, to get to whatever my cost for 0 people are. So 275 minus 175 leaves me 100, so it'll cost $100 for 0 people. For C, when I look at the equation, usually it's y equals mx plus b, then I know my rate of change is going to be the number in front of the n. 1650 is the rate of change, and 75 is the initial value. So that tells me if I want to compare these 3 different relationships, I can tell the rate and the initial for each one, A, B, C. A has a rate of 175 per 10 people, or 1750 per one, and an initial value of 100. B has a rate of change of $15 per person with an initial value of 100, and C has a rate of $16.50 per person and an initial value of 75. So with my summary table, I can see that the cheapest rate or cost per person is in fact B. I can also see that the cheapest starting value is in fact C at 75. What I'd like to do is actually create a graph with all 3 of these relationships so I can see how they compare. So in order to do that, I'm going to use a table of values to figure out a couple of points for C. So I'm going to move over and create a table of values. So I know that the number of people controls the cost. So if I have 0 people, it's $75. If I have 10 people, then I'm going to put the number 10 in for n and add 75. The cost becomes $165 plus $75. So that cost becomes $240. And I can do the same again for perhaps 20. So $16.50 times 20. Add 75. So that's going to be double 165, 3, 2, 330. So I get $405. Now I have a couple of points that I can plot on the graph on the other page. So, zooming into just the graph, I have 0 costs me $75, 10 people cost me $235. 10 following up, 200 and about there. And I can draw a line in from here to approximately there, and we'll make it red. Okay. Also, I want to include the information for Hall C, and I will do Hall A, and Hall A I will do in blue. So it also has a cost of $100 for 0 people, and a cost for 10 people is $275. So I can plot that point here, and I can join up my line from there to there, extending. So I have Hall A and Hall C, and the black one is Hall B. So there are a couple of things that I can say about this relationship then. At the start, it appears that for 0 people, the cheapest option is Hall C. At some point, the halls are going to switch from cheapest to not as cheap. So if I continue extending, I see that in this direction, eventually Hall C's cost will overtake Hall B's cost. What about comparing the line of B and the line of A? Will Hall A ever be less expensive than Hall B? This one. Well, these two lines currently have the same starting point, as I noticed in my initial comparison down here. So they both start at a cost of $100, and Hall A rises at a faster rate than Hall B, so actually Hall A will always be more expensive than Hall B. The answer to the question that was posed in this problem, which Hall's total cost includes a lower cost per person, the cost per person is my rate of change. So if I compare the various rates of change, 1750, 15, and 1650, the cheapest cost per person is always Hall B. One more thing that I can say is that a point such as this point right here, 5, 175, has meaning in the context. The meaning is that 5 people, because that's the number of people that 5 is labeled on, costs $175, and $175 is related to the Y variable, or total cost. So we can interpret our graph in the context of the problem. A final thing that we can calculate now that we actually know the rate of change and the initial value for each of these relationships is the equation. So we have the equation for Hall C already. Hall C equation is C equals 1650n plus 75. And I can write Hall A Cost is equal to the rate of change, or the cost per person, $17.50, times the number of people, add the initial or booking fee of $100. And hall B is the cost is equal to $15 times the number of people plus a $100 booking fee. I can use these problems to also determine the cost for a certain number of people. So the cost for each of these different halls, if I knew I was going to have, if you're going to have 35 people, what would the cost be? Okay, so I can use the equation for hall A. Oops, that's not hall A. And I am looking for cost. I need to determine the cost. So C is the thing I don't know. N must be the thing I know. The N stands for number of people, so I have 35. I'm going to replace 35 in for N here. I'll need my calculator. So calculating 1750 times 35 gave me 612.50. Plus I need $100. So the cost will in fact be $712.50. So I could work out the cost for each of the other halls using equation C and using equation D as well.